Welcome to the Environmental Analysis System Spatial Analysis plugin demonstration. In this demo, we will discuss some of the operation and usage of the Spatial Analysis plugin, a module that works with the Environmental Analysis System, or EASY, marine GIS software. Spatial analysis is one of many tools within EASY that facilitate the creation and usage of advanced data fusion platforms for a variety of needs. Here, we see a spatial analysis project focusing on the Indian Ocean and coastal Oman. After data are ingested into a project, spatial analysis allows the user to perform multivariate time series analyses of the data, providing an essential tool for spatial data modeling. The user can output results to external CSV files and can also view and export a range of generated plots and images. In addition, the user can run a simulation which allows for simple and useful viewings of station data over a designated time series. These data can be overlaid on top of satellite and modeled imagery for even more powerful visual analysis. Here, we see shapefiles of Oman and the surrounding region, along with satellite imagery of monthly chlorophyll. We can change the displayed image by using the Browse Images toolbar here. Let's change to some modeled sea surface temperature imagery. Note that we can also change the date of the displayed imagery using the same toolbar, as well as the frame. This particular imagery has multiple frames of temperature at different depths. While viewing imagery, the user can easily generate some basic data about the imagery currently displayed. As the user moves the cursor, the bottom right corner of the main screen displays the latitude and longitude of the cursor. By holding down the control button while clicking, EASY displays the imagery value at the cursor location. By holding down Shift and then clicking and holding the left mouse button while moving the mouse, the user can create a transect line starting from the initial button click and ending when the user releases the mouse button. The length of the transect is displayed at the bottom right of the screen, along with the angle of the transect. The imagery values along the transect path are also displayed in the image profile plot displayed at the top left. This plot is one of many plots available in EASY. To add a new plot to the main screen, go to View, Data Graphics, and select the Plots tab. We will add the bitmap profile plot to the main screen by selecting it in the menu here. The bitmap profile displays a curtain plot of imagery values at different depths along the transect line. As with many plots, the user can right-click on the plot to bring up plot options. In this case, the Plot Options menu allows for selection of depth range and number of depths plotted, and also allows the user to export the plot image as a bitmap file. We will now switch to a new project to discuss additional spatial analysis functionality. Here, we see a spatial analysis project that incorporates tuna fisheries catch data with satellite and model imagery of the eastern Pacific Ocean. The data currently displayed are historical catch data of skipjack tuna by the purse seine fishery of the eastern Pacific Ocean. The catch data are gridded into 1-degree stations and are overlaid on top of MODIS annual chlorophyll satellite imagery. To change the displayed station data, we use the Blobs tab of the Data Graphics menu. Let's change to YFT yellowfin tuna data. Note that the stations have different colors depending on their average value. The values of each bin are displayed in the upper right corner of the screen, along with the legend of the underlying imagery. The user can easily change the number of displayed bins, ranges, colors, sizes, etc. with the Blobs tab. Other tabs of the Data Graphics menu control image contouring, underlying imagery during a simulation run, and displayed plots. To bring in additional station data into a project, the user can use an integrated virtual database wizard. The virtual database wizard has step-by-step instructions on how to bring in new data from a CSV or text file. More information about this process can be found in a comprehensive help PDF file that is located in the EASY Documents subfolder. The user can also use the Data Filters menu to set up one or more filters to restrict visible and analyzed data. Filters can include different voyages, species, sensor types, and specified ranges of latitude, longitude, depth, time, and measurement values. Data can also be analyzed on a seasonal or non-seasonal basis. By default, the displayed data shows averages over the entire designated time series. The user can change the start and end times by going to the Simulation tab of the Display Settings menu. Here we can also change the display delta of the simulation time. As our fisheries catch data is on a monthly time scale, we will leave the display delta set to months. Other noteworthy tabs in the Display Settings menu include Menus, which allows the user to change the amount of visible project controls depending on familiarity with operation of Easy, Overlays, which controls overlays and shapefiles, Settings, which controls a variety of graphical settings and controls, Plots, which allows the user to create and modify various plots and calculated false color imagery, and Categories, which allows the user to add or remove imagery categories and modify already existing categories, including displayed imagery minimum and maximum values. To run the simulation, the user can bring up the Simulation Control Options menu and simply press the play button to begin. Here, we see monthly yellowfin catch data as the simulation runs. We can also display one or more types of satellite or modeled imagery underneath the station data. To do this, we bring up the Data Graphics menu and select the Images tab. Let's display Grist sea surface temperature and continue running the simulation. We can immediately see linkages between the yellowfin catch data and the underlying imagery. The user can easily import imagery using the Configure Import Services menu. This menu allows the user to bring in different imagery types from multiple sources. Here in the Folder tab, we see available imagery types along with a pointer to the local source of the imagery files. The user can easily bring in additional imagery from a local drive by simply specifying the location of the imagery and then pressing Scan, selecting the desired imagery files, and then pressing Add. Easy will read, process, and import the selected imagery into the project. Easy also has the ability to automatically download and import imagery from the internet using either HTTP or FTP addresses. Here we see an example of the settings for online importation of MODIS 2 monthly chlorophyll imagery. After these settings are designated, the user can simply press the polling button in the main screen toolbar, and Easy will access the internet, check for new available imagery that is not yet registered in the project, download and unpack said imagery, and import the new files into the project. Another useful feature built into Easy is the ability to average multiple imagery files into one or more new imagery files with broader temporal resolution. For example, the user can use the Merge Images function to combine daily sea surface temperature images into averaged monthly imagery. The Merge Images functionality is quite powerful and allows for seasonal or annual averaging, user-specified spatial and temporal extents, and choice of averaging functions. Once the menu options are specified, simply press Process, and Easy will generate a new set of averaged imagery that can then be imported back into the project as previously discussed. The core functionality of the Spatial Analysis plugin can be found in the Spatial Analysis Options menu, which can be accessed by either right-clicking on the main window or by selecting View Spatial Analysis Options in the main toolbar. The Measure tab allows the user to select a measurement of interest, specify spatial and temporal extents, define related environmental characteristics and their value ranges, and set controls for analysis and display. The user can then run a spatial analysis that matches the measurement category to the underlying environmental characteristics. This process creates a matrix consisting of data, time, latitude, longitude, depth, and measurement value, as well as characteristic values for all samples selected in the characteristic box. The binned data is also input to a discrete probability density function of samples and values, as well as an ANOVA, which is accessed in the associated ANOVA tab of the Spatial Analysis Options menu. Here, a spatial matching has already been run, matching yellowfin tuna catch measurements to the underlying environmental characteristics shown here. After a matching has been completed, spatial analysis provides various interpretations of the results, and the user can also export station statistics, generated lookup tables, and other output including predicted habitat to an external file. Other tabs in the Spatial Analysis Options menu include the Density tab, which allows the user to visualize sample density probability distribution based on selected physical characteristics. Modifying settings here controls the sample density probability plot seen at left, which shows a visualization of the probability that a sample will be found at any combination of the two selected physical characteristics. This tab also controls false color images of predicted habitat, which will be demoed later in this video. The Correlation tab allows the user to analyze and visualize correlation between any two physical characteristics specified in the Measure tab. Easy queries the matching matrix in order to plot values of paired categories as a simple linear correlation, which can be seen in the characteristic correlation plot at left. The Drift tab allows the user to drift selected measurement samples forward or backward in time using echo ocean currents. The ANOVA tab allows the user to perform an analysis of variance on sample characteristics and export the analysis results. Finally, the Scenario tab allows the user to save analysis settings created in the Measure tab. This easy capability is important for multi-step or iterative spatial analysis. It saves the analyst's time and computing resources from reading the same data more than once. By creating a unique scenario for each different matching run in the Measure tab, the user can easily save and load different scenarios for more in-depth analyses. Spatial analysis also has the ability to create and display false color imagery of predicted habitat of a designated measurement category. Marine organisms, ranging from plankton to large marine mammals, have been common measurement categories in many easy projects, and the ability to analyze and visualize preferred environmental conditions has proven to be a powerful tool. After running a matching, the user can select predicted habitat in the Images tab of the Data Graphics menu. Then, when a simulation is run, EASY will use the lookup matrices generated from the spatial analysis measurement matching to generate false color predicted habitat maps from underlying satellite and model data at every time step of the simulation. Here, we see predicted habitat for yellowfin tuna being calculated and displayed as the simulation runs. We will now switch to a new project to discuss additional spatial analysis functionality. Here, we see a project that includes environmental and survey data from multiple datasets taken in and around Long Island Sound in New York. We are currently looking at chlorophyll A station data overlaid on top of modeled water temperature imagery. By clicking on an individual station, the user can see information about the data collected at that station, including voyage name, station location, sensor type, and the collection date, time, depth, and value of each data point recorded at that station. By pressing the Plot button, EASY will generate a plot of the selected data over time. This plot is one of many available user-defined plots, which can be seen in the Plots tab of the Display Settings menu. Here, the user can create new plots for individual stations or an entire dataset, and can create plots including measurement value versus time, measurement value versus depth, or measurement false color image. Other options like minimum and maximum measurement values can also be selected in this menu. When a measurement false color image is chosen, the user can also control interpolation options including range, reach, and interpolation resolution. After a false color image is designated, Easy will include a new imagery type that can be viewed using the Browse Images toolbar. We will change the background imagery from water temperature to the newly created chlorophyll false color imagery. Easy has generated this new imagery by interpolating pixel values between average station values for the designated simulation time. The user can modify various aspects of the new imagery category by going to Display Settings and choosing the Categories tab, then navigating to the newly created imagery type. By pressing Edit, the user can change settings like function type, as well as the imagery minimum and maximum values. One can also modify the imagery palette by right-clicking on the screen and bringing up the palette window. Refer to the Comprehensive Help PDF file located in the Easy Document subfolder for additional information about these options, as well as other useful information and tutorials. This concludes the Easy Spatial Analysis demonstration. Thank you for your time.